Good afternoon, everyone. We are going to start our program, and we would like to request everyone to stand for the Philippine National Anthem.
Bayang magiliw, peros ng silanganan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyat ka ng magiliw, sa manlulupi, kita masisingil, sa dagat at bundok, sa simoy at sa langit mo bangag, ay nilang ang tula at awit sa paglayang tinamahan. Ang kisap ng watawat mo'y nagumpay na nakikinig, ang bituin ng araw niya kailan magpapay pagkikinig. Lupa ng araw ng maraming pagsita, kulay langit sa likod. Aming ligaya dapat may mamagin, at namatay ng tayo sa'yo.
Thank you. You may all sit down. Good morning, good afternoon, or maybe there's somebody joining. Good evening, everyone. Welcome to the 14th Farmers Exchange Program. This is day one of our 5-day webinar that will start today until Friday, so November 16 to November 20. And I am your moderator for today. I am Sonny Tababa, Biotech Affairs Director of CropLife Asia. I would like to welcome our participants coming all over from various provinces in the Philippines, as well as from other countries. So we have participants coming from Singapore. We have also from Korea, and then maybe I will acknowledge all the rest as we go along. And for this 5-day webinar, we prepared an exciting program for you. We have different speakers, international speakers, sharing their expertise, as well as progressive farmers who will also share their experiences in farming and what make them successful farmers despite of the challenges. So let's get on with our webinar. To give us the welcome remarks is our CropLife Asia's Executive Director. What is CropLife Asia? So CropLife Asia is the Asian operation of an international plant science industry association. We are called CropLife International with headquarters in Brussels. CropLife Asia's headquarters is in Singapore. Now, our Executive Director earned his Master of Science in Genetic Engineering from University Putra Malaysia and a PhD in Molecular Biology Plant Virus from Okayama University in Japan. He is a recipient of many awards, among which is the Silver Award at the 2005 Geneva International Exhibitions and Inventions of New Techniques and Products. He is also a U.S. Government Cochrane Fellowship awardee for biological research at Case Western Reserve University in Ohio and the University Putra Malaysia awardee for research and development. Without much ado, may I call on our Executive Director, Dr. Xianghe Tan. Xianghe, the floor is yours.
Thank you, Kasani. Thank you for the warm welcome and the brief introduction. If today or this year is not COVID, probably you're standing behind the corn plantation that you see. Despite the graduates that you saw, I'm very much a farmer myself. This is the plantation I used to run in Malaysia, 900 hectares of corn farming. This is one of the small projects that I did before I joined CropLife. So coming back is I really appreciate the stakeholders that are on the ground because I have gone through the pain of growing corn and many other agricultural products in the before I joined CropLife. So again, CropLife represents the technology provider. Every year, we put in about $6.5 billion into R&D for both crop protection and plant biotechnology, including seeds and genetics. So agriculture has been our core value and business model for many, many years. So we did everybody, with COVID, you're seeing so much technology that has been moving, etc. Just like today, we have migrated into WebEx and Zoom, but innovation continue to put in the hands and in front of us to adopt. Just like biotechnology, in the farmers with the farmers, we want to bring technology innovations in the arms of the farmers, so that we can work closely with regulators, stakeholder, and value chain. And most important, our front runners, the farmers, despite COVID, we can work from home. Between COVID, the farmers continue to bring safe and secure food in the farming environment, and they have faced with so many other threats and challenges. And this is where we, as stakeholders, as developers, needs to come together to make sure that we continue to enable both men farmers, women farmers, whether you're big scale, small scale. The innovation is the core for us to continue to produce under so many challenges, such as climate change, whether it's fall armyworm, whether it's locusts. We're seeing so much challenges, but unless we can come together to bring and enable technology to be delivered in the hands of farmers in a meaningful manner and in a timely manner, we won't be able to continue to support whether it's the Philippines government and etc. to work on poverty eradication, to address zero hunger, and never, last but not least, is also to provide national stability, resiliency in national agriculture GDP. This is where we are today. Post-COVID, it's going to be a very different market, and it's only technology and innovation is crucial for us to ensure that the technology is put in the hands of farmers so that we can continue to produce and secure food for the whole nation. And I welcome all of you to this 1 week of discussion. I'm sure there are a lot of very experienced speakers around, and we're more than happy to share the experience, including people like me who have farmed both. As I said, I farmed in China, in Cambodia, and also Indonesia and Malaysia on a first hand. With that, welcome everyone. Kasani, back to you.
All right, thank you. Thank you very much, Shanki. And it's also to acknowledge your unwavering support to make this event a yearly event since 2007. And before I introduce our first speaker, let me just give some points to remember to our participants for the duration of the program. So we have a Q&A box. You can see that at the bottom of your screen. Please type your questions at the Q&A box anytime. Questions will be answered during the Q&A session, and we will also try our best to answer all your questions in the chat box or in the Q&A. And then if we are not able to answer it during the session, then we are going to answer that through your email. And for participants who will complete their attendance in 5 days, you will receive an e-certificate. So the e-certificates will be sent to your registered email address. And then we have a $20 question. What is that? So at the end of the session, we will pose one question only. And so we want you to stay until the very end of the session. That's a very fun part. Okay. So So moving on to our first speaker. Let me introduce. She is the director of Southeast Asia Center and Director of the Global Knowledge Center on Crop Biotechnology of the International Service for the Acquisition of Agri-Biotech Applications. Many of us know this as ISA. She leads the development and publication of the annual Global Status of Commercialized Biotech GM Crops, or we know it as ISA briefs. She has published 31 papers in scientific journals and proceedings, as well as chapters in two books on biotechnology. She holds a PhD in botany from Purdue University, Indiana, USA, and postdoctoral fellowship at Albert Ludwigs University in Germany on golden rice. Today, she will give us an overview of modern biotechnology, which includes its adoption, status, and products in the pipeline. I'm very happy, and please join me in welcoming Dr. Rodora Romero Aldemita. Dr. Ola?
Thank you so much, Sonny. I thank you very much for inviting me over. ISA has been a part of the Farmers Exchange program every year. And of course, this is a very different scenario as we are in a live telecast, a virtual telecast. And we also have, are we on Facebook? No, we're not. Okay. So, and I'm also very thankful for CropLife Asia for supporting the Southeast Asia Center at ISA for various projects that we're holding right now. So to start, I'm going to talk on the topic assigned to me, which is there. Um, okay. So this is an overview of biotech crops. And apologies that I am going to present to you the status for 2018. We're still putting together and finishing up the 2019. So let's start. And I hope that our participants would understand. I will try to talk very simply and very slowly. So what is biotechnology? So my talk would be on biotechnology, and it's on any technique that uses whole or part of a living things to make new products. So these could be plants, animals, and other organisms for specific use. So take note that we only do this if there is no other way in the conventional means. So this used to be the last resort in improving our crops, animals, and other organisms. But currently, with the many advantages of using biotechnology, most of the technologies most of the biotechnologies are being used for speedy production of these organisms, for plants, animals, and other organisms. And you may take note also that it is a multidisciplinary field. So it's not only genetics, it involves microbiology, genetics, biochem, engineering, computer science, medicine, agriculture, forestry, and immunology. And so during the previous years, many years ago, we were only involved in conventional biotechnology. So you can look here at the Egyptian way of doing agriculture before. And actually, this is a slide which I borrowed from our resource speaker, Dr. Oh, I forgot her name, but I will tell her later. And so this will tell you that biotechnology has been used for preparing bread from wheat, for beer, for wine, cheese, and in the Philippines, we have this biotech product. So we'll have these are familiar things to us, and we're enjoying this because of conventional biotechnology, which involves fermentation. And of course, those live organisms. So, for example, Yakult, as live organisms, as prebiotics, probiotics for our tummy, so that we can have a good stomach flora. Okay, so these are fermentation products. Another one of the successful biotechnology that has been adopted in many countries is the use of tissue culture. So tissue culture is the regeneration of plant parts in the laboratory from other plant parts. And examples of these are tissue cultured citrus, pineapples, avocados, mangoes, bananas, coffee, and papaya. And I know that in Asia, especially in Thailand, these are tissue culture are also being used for ornamental crops, for orchids, and so on. So tissue culture has been there, and it is considered as a low-end biotechnology. So it's considered now as conventional biotechnology, but it is an integral component of agricultural biotechnology, and we have been using this for the last maybe 20 or so decades. Now, modern biotechnology is a collection of scientific techniques that used that are used to improve plants, animals, and microorganisms based on an understanding of DNA or deoxyribonucleic acid. So biotechnology allows the improvement not by traditional breeding alone. So as scientists discover each of the items involved in modern biotechnology, many procedures have been started and it is improving. And currently, from conventional modern biotechnology, so we are now using the word conventional modern biotechnology, to the new genome editing technology, which are new plant breeding innovations, biotechnology has expanded, which makes it easier for our scientists and crop producers to improve these organisms for food sustainability. These are plants, animals, and microorganisms. So, what is the basis of biotechnology? So, you're looking at this slide, you will see that each one of us is composed of cells. So, within the cells are nucleus, and the nucleus contains the chromosomes, and the chromosomes have this pairing of adenine, thymine, and guanine cytosine. And these pairings are conserved from in all organisms. So you can just say that from animals, humans, plants, and microorganisms, DNA is there. And it is possible that an organism from microbes can go to or can be incorporated into plants, and vice versa, as long as you are targeting a certain trait that you want to be improved in the recipient organism. So possibility of doing things becomes broader as we understand the DNA or the genetic sequence of organisms. Okay, so now let's move into how are we developing biotech crops or biotech animals and biotech organisms. So first, I told you that the basis is the DNA. So the gene that you're interested in can be isolated from the source organism. It can be incorporated into a gene construct, and then it is going to be incorporated into the plant cells or animal cells through methods of genetic engineering. And this is when we use Agrobacterium tumefaciens or the particle bombardment. These are the two most popular ways of introducing cells into organisms. And so we have done that in many organisms. And for example, so this is rice. We have introduced a certain gene into rice cells, callus, and then we produce some regenerable callus, and they are producing plants here in a test tube. And then you test that in the greenhouse, and then you do a field testing afterwards. From each step of the way, countries have put together their biotechnology framework so that each step of the way, scientists and regulators can see how things are going and it follows the safety procedure in the country. And safety procedures in each country follow a standard procedure. So it is important that each country has its own national biosafety framework. So the potentials of biotechnology have been increasing after the development of those methodologies. We can see that biotech products are now being used for fighting disease, in increasing yield, in environment friendly way, in safer crops because you don't use any more a lot of chemicals to 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 um, to control the pest. You can do it through an integrated pest management, so that you can see it depends on the occurrence or the incidence of the pest. So sometimes you have to use the chemicals if there's really a lot more or more diverse insect pests in the crop. So integrated pest management is a part of controlling the diseases or the insect pests in a field. Now we also have nutritious food. If you're familiar with golden rice, which will be presented by Dr. Renke later, and then better for the industry. One of the applications here is the production of crops which have higher biomass, which can be converted into biofuels or um, and then will be used later in many industrial ways, and of course raw materials in the industry. Now, looking at the 1996 to 2018 data, you see that it has been 22 years that Vita crops have been planted. This is the 2018 data. And we have already gained ground. And there were 191.7 million hectares planted to Vita crops. And so you will see here that there are now more developing countries, or the area planted to Vita crops in developing countries is higher compared to the industrialized countries. So these are the industrialized countries, and you see that in 2012, there was a 50-50 or 1:1 a percentage, but now there are more Vita crops planted in developing countries. So that is us, developing countries. So in 2018, there were 26 countries which planted Vita crops. You can see here 46% in North America, 42% in South America, and then we have 10% in Asia, 1.5 in Africa, and 0.5% in Europe. So you can see here the 26 countries, and you can identify where you are in the 26 countries. So I'll see you later. I'll show you later. In 2018, there were 9 Asia Pacific countries, 2 North American, and so on. So globally, 78% of the total soybeans are already biotech, 76% for cotton, 30% for maize, and 29% for canola. But it shows here that we have a lot of areas to be planted with biotech maize because it's only 30%. And to think that maize is very much needed in all of our everyday food, everyday living. And so it is important that we try and, well, tell our regulatory people or tell our farmers or help disseminate the information that biotech maize can help in supplementing our maize requirements in our countries. So this is what I'm telling about. So there were 9 planting countries and 8 importing countries in the Asia Pacific. So you can see your countries there. The 9 planting ones are here. They are colored green. So we have China, Vietnam, Philippines, Indonesia, Australia, Myanmar, Bangladesh, India, and Pakistan. And the importing countries or regions are these countries. So all in all, the Asia Pacific region has been adopting Vita crops, and Indonesia was the latest addition to the group of planting countries. Now, in terms of crops, it is still biotech soybeans, which is leading, and it has retained its 50%. Um, do I have time? Yeah. It has retained its 50% of the global area. And then we have followed by maize, cotton, and then canola. And so ISA, if you would like to see the current activities in terms of approvals, you can see that we have a ISA GM approval database, and the US has the most number of approvals, and maize has the largest number of approved events, and herbicide tolerant corn or maize has the most approvals. So this has been updated, and you can check whether your country is represented in this GM approval database, and you can help us if we are reporting it correctly also. So now let's move at how we are expanding by the crops. So before we were only producing these major crops like corn, soybean, cotton, and canola, but globally we have already extended to potatoes, eggplant, alfalfa, and apples. So these are the areas which are cultivating these food and feed crops, and reports will show that they have increased in 2019. So in 2018, these were the new crops and traits planted. So we have in Brazil, insect-resistant sugarcane has been planted, and then it's a best solution to cane borer. And then we have a drought-tolerant sugarcane in Indonesia, and we have safflower in still in R&D in Australia, but will be deployed in a larger scale in 2020. These are still the Vita crops and traits in the pipeline. So we have rice, golden sorghum, drought tolerant wheat, delayed ripening papaya is still being delayed. We have this in Fusarium wilt and Sigatoka and Bunch-top resistant and beta carotene enriched bananas in Africa. And we have pigeon peas in Africa, as well as mosaic and brown stick resistant cassava, ongoing trials in Africa. And then we have beta crops and traits more. We have beta carotene enriched potato. This is still being done. High yielding and drought tolerant soybean, chestnut blight resistant tree in the US. Yeah, late blight resistant potato. There are still many initiatives on this because late blight potato is a very devastating disease in Europe and the US. And we have citrus greening resistant citrus. So to end my talk, we are still looking at biotechnology as an important component to meet increase by 50% the food demand by 2050. These were papers published in 2019, and this was, I think, 2017. And the FAO has highlighted the importance of biotechnology because in our area, in the Asia Pacific region, we still have problems on population growth, aging, especially in our farmers, climate change, agricultural productivity, and all of these are still there. So biotechnology is still a very important component of meeting these problems. So with that, thank you very much. And this is an old slide, should be brief 54. And thank you very much. And please put your questions in the Q&A box. See you later.
Thank you very much, Dr. Aldemita. You just said what I am going to say to type in your questions in the Q&A. We are actually now in our Q&A portion. So I see a question in a Q&A. Uh, well, it records here. It says here from. It's no longer there. Okay. So here is another question, Dr.
Sorry,
Ola.
Sunny,
Um,
I
oh,
I answered that question, and I don't know whether I should have or not, but please check it. If you look in the answered questions part of the section there,
okay. I'm
okay,
very happy I see you now, Dr. Rinky.
yeah,
Okay. So, okay, thank you very much for answering that question from one of our participants. I'm not very sure if I think from Pakistan, but let me just use this a
mm,
little time to greet our participants. We have participants coming from China, from Korea, from Taiwan. We have from Pakistan, from Thailand, Australia, and Indonesia. So we have a diverse group of participants this afternoon. So here is a question, Dr. Ola. Um, there is golden rice and BT eggplant. Are there other public sector products very near to commercialization?
In the Philippines, of course, Dr. Renki is going to talk about that. For the BT eggplant, we're still moving on. And with with the current situation of COVID, there should have been trials of delayed ripening papaya and BT cotton. So those are the four public sector biotech crops in the Philippines, pipeline in the Philippines. In the different countries, there are very many diverse ones. So, for example, in India, there are so many vegetable crops that are being genetic or improved through biotechnology, genetically engineered ones. In Indonesia, we have late blight resistant potato, and we also have golden rice, and there was abiti eggplant also. And then in Bangladesh, we have several. We have cotton, BT cotton, and potato also, late blight resistant potato and golden rice. Um, in Pakistan, most of the activities are still in the laboratory research or in laboratory level, but we're still waiting for farmers to start adopting the biotech maize, which has been approved in 2016 and still is not in the field. For China, China is leading in research, but of course, it's different when you go to commercialization. There's a lot more problems, sort of. Still is tricky that over there in China. So, but research there is very good. Have I missed anything? Oh, Myanmar. Myanmar, they are looking at cotton. Of course, they have BT cotton, and they would like to diversify their source of resistance to Lepidopterus insects. And then they also are interested in commercializing maize and soybean, but research is still not there.
Take some water.
Sorry.
Thank you very much, Dr. Ola. I have here a second question, but since it refers to a question is about the golden rice, so we will park that question. Doctor, I think comes from Dr. Nippon. We'll park that question after our speaker, after our golden rice speaker, which is very timely. Okay, thank you so much. Let us all together thank Dr. Rodora Romero Aldemita for this very instructive presentation. And without much ado, may I move on to our next speaker. He is a senior scientist and rice breeder, the biofortification lead of the Healthier Rice Program of the International Rice Research Institute, which we all know to be known as IRRI. He is from Australia and spent much of his career developing rice varieties for the rice industry in New South Wales and Northern Victoria. He has a particular interest in developing highly productive varieties while matching grain quality with market requirements. His current focus is making rice more nutritious through biofortification, using conventional plant breeding to improve zinc content and transgenic approaches to improve zinc, iron, and vitamin A content in rice. Today, he will talk about the golden rice experience, the status of the golden rice research. Let us all welcome Dr. Russell Rinke. Sir, the floor is yours.
Thank you. Thank you very much. Now, I'm just a little concerned that I might have entered the meeting using the wrong link and that I'm not in a position to share my presentation. And I do apologize for this, but this is one of the occupational hazards, isn't it? So can I just ask for one of your technical people? Is Bowie there?
Can you try to share your screen?
So the thing is that okay. I do have that option, and let's see if this works. I do apologize, folks. Now, what can you see?
It's very good. We see your screen now.
Wonderful. Okay. So just give me one moment. Now I have to go to here. All right. I'm I really struggle sometimes with these online meetings because I really like to be able to see everyone and to interact with people a little bit. And so to all of the participants this year, welcome, and I sincerely apologise that we can't be meeting face to face due to the current circumstances. But anyway, let me go through my presentation, and I encourage you to ask any questions that you might have at any point, and obviously I'll deal with them as and when I can when I finish the presentation. But my name is Russell Renke, and I'm the lead for the Healthier Rice Project at IRRI, and together with our partners in the Philippines and in Bangladesh, so that would be PhilRice in the Philippines and the Bangladesh Rice Research Institute, our work is aimed at improving the nutritional quality, the nutritional value of rice. And the first thing that we're doing there is through the inclusion of beta carotene in the milled grains. So that's primarily what I'll be talking about. And that's why we call it golden rice, because when we make that change to the rice, the grains become a golden color. And that's due to the carotenoids that are being produced in the grain. So my background, though, is very much in conventional plant breeding. And for very close to 30 years, I was working in Australia, developing new varieties of rice for the New South Wales rice industry. So I can clearly see the benefit of both aspects, okay? You need conventional plant breeding to assemble high quality genetic backgrounds, in other words, varieties that will perform well in your particular area. And then I'd argue you really need these days biotechnology as well to add the additional traits in a very precise manner that can be really useful for dealing with climate change, with pests and diseases, or in my case, improving the nutritional value. So today I'll just review our progress as we work our way through the regulatory approval and then talk to you about the pathway for deployment of golden rice. So you might wonder why we're focusing on improving the nutritional value of rice. And that's primarily because even in 2020, there's still 2 billion people who continue to suffer from what we call hidden hunger, which is essentially due to a lack of nutrition of what we call the micronutrients. So there are a number of micronutrients. So vitamin A clearly is one of those, but also various elements as well. Iron and zinc are another couple, and then there are various other vitamins as well. So it just astounds me that in this day and age, there's still so many people who suffer from micronutrient malnutrition, and an even greater number who simply don't have the resources to be able to afford a healthy diet. And I think that the current pandemic that we're currently facing, it really underscores the need to improve the nutritional status, because very often these micronutrients are involved in mounting, in us having a good immune system, a well-functioning immune system. And of course, that's critical for facing some of these diseases. Now, I'm not arguing for a moment that that even those of us who have adequate nutrition, if we haven't been exposed to the disease before, then clearly we have no sort of immunity to it. And that's why we need to go down the route of vaccinations. But for all of the diseases that have been around for a while, and the immune system is able to mount a response, if you don't have enough of these essential nutrients, then it takes you longer. And so there's a huge amount of suffering because people don't have adequately functioning immune systems that then take longer to fight off various diseases. So if we are to provide good nutrition globally, to all of those who need it, then there clearly needs to be good policies, and I would argue a series of interventions as well. So special things that we can do to improve nutrition. And there's a global panel on agriculture and food systems for nutrition that is calling for a transformed food system for the future. And that's the way they define it, is to say that this is a food system that can provide support through relevant policies, government policies, nutrient-rich staples, and I'm going to read this off the screen here, that are available, accessible, affordable, and desirable for all. Now that's a big call, but I think that's absolutely critical to make inroads into this ongoing, this intractable problem of people not having enough nutrition. So there are a lot of different approaches to address micronutrient deficiencies, and I'm here to tell you today that all of these have a lot of value. Firstly, I would really personally love to see everyone have access to balanced diets, because dietary diversity is one of the key things that enables you to actually have enough nutrient to meet all of your needs. There have been various interventions and approaches to improve the rate of breastfeeding, which is really important for early childhood development. There has been a lot of work on providing specific supplements to address particular nutrient limitations. Also food fortification. So in other words, adding in something, and I guess one of the classic examples of that would be adding iodine to salt, and that's become a very widespread fortificant that has dealt with the difficult problem of iodine deficiency. And the last on those lists, and on that list, and I would argue perhaps the most recent, is biofortification. And that's where we simply build in the improved nutrition into the variety. So let me explain in just a little more detail about what ways that we can actually use biofortification. So it is simply the process by which the nutritional value of crops is improved through either, and it can be through agronomic practices, it can be through conventional plant breeding where that works, or we can take the approach of using modern biotechnology as well. So one example of using a modified agronomic treatment would be if you were to use a foliar spray, for example, when the crop is during its grain filling phase. There have been experiments done where you use a foliar spray of zinc, and then that gets translocated into the grain, and you end up with grains that have a higher zinc content than they normally would. So that's one example. But as you can imagine, that's not simple to do, right? You've got to have the foliar spray there. You've got to have a means of getting it onto the crop, and you've got to do it at the right time. So actually building it in through breeding is perhaps the most sustainable and low cost option in order to improve the nutrient value of crops. So when there's naturally occurring variation, if we can find some varieties that have higher levels of particular nutrients, then it's a relatively straightforward process to use conventional breeding and cross those with the best varieties that we have available. And providing we put on the appropriate selection pressure and make sure that we maintain that improved nutrition, we can develop new varieties that carry those genes forward. But if such variation is not present, and that's true of beta-carotene in rice, so there's no known rice variety that actually puts beta-carotene or carotenoids in the grains. So in this case, we had to take a different approach, and we actually had to use biotechnology to transfer additional genes into the rice in order that it would produce the carotenoids in the grain for the health benefit. So there's a number of factors that are necessary for this to be a successful approach. And you've clearly got to put it into varieties that farmers can use and will readily adopt. And so some of these factors have been outlined in a relatively recent paper, and they say you have to have attractive traits at attractive costs for farmers and consumers. And I'll get into that when it comes to golden rice a little later. It has to be, of course, in the case of nutrient interventions, there have to be adequate levels of the particular nutrient, and it has to be retained in the grain after it's been through all of the processing, all of the storage, and all of the cooking processes. All right, so there's many opportunities there for the value to be diminished. And then once it's consumed, it has to be converted in the human body in an effective way. And so it has to demonstrate efficacy for human health. So there also has to be a considerable education program. So we need to talk to farmers about this, but not only farmers, but also consumers and all of the actors in the value chain that gets the rice from the farm to where it's ultimately consumed. Now, sometimes the rice is milled and eaten by the people who grow it. So there's a very small sort of a few actors in the value chain there. But if we're serious about meeting malnutrition, say in urban slums, we have to have all of the players in place that allow that rice to be grown, milled, and then transferred and marketed to the people who need it. Some people ask whether a rice-based solution makes sense. And I think the answer is fairly straightforward to that. And of course, in countries where rice is a staple part of the diet, because it's eaten, in significant quantities and with a lot of frequency, if we can make even tiny changes, it can have a huge impact on human health. So if you look in the Philippines, for example, many households spend almost a third of their daily food cost goes on rice. And it's a huge part of the daily diet. If you're a Filipino, you know that very well. And it's true of many other countries too, okay, where rice is part of the diet. And I'm particularly aware of what it's like in Bangladesh, because on all of my visits there, when I have a meal with people, I'm presented with a plate with a mountain of rice on the top, much more than I'm used to eating. So, of course, with such a high proportion that is spent on purchasing rice in the diet, it's even more exacerbated when in poorer households where they have fewer resources, and you often find that that it consumes a much greater proportion of the income of the poorer people. So in Bangladesh, remember I was talking earlier about how if you can have a diverse diet, then it's usually a much more nutritious diet. But sadly, 13% of the Bangladesh population, as in a publication as recently as 2019, notes that proportion of Bangladesh population cannot afford a balanced and nutritious diet. And similarly to the Philippines, the ultra poor spend around 40% of their household income on rice. And even though we've had many programs to diversify diets, there really hasn't been a significant increase in national vegetable consumption. And it wouldn't surprise me if that's not somewhat similar in the Philippines as well. So some of these things are quite self-evident, but you know that rice is the staple food for more than half of humanity, really. Many scientific papers begin with more than half of the world's population depends on rice. And as I noted before, if we can make even a small change in the micronutrient content, then it could have a significant impact on human health. I'm going to talk to you about golden rice and where we are with that, but we have other innovations that are waiting in the wings that are ready to go, but have to move through the regulatory process, and that includes high iron and zinc. And what we find is that many times when the population is suffering from one micronutrient deficiency, very commonly they're suffering from multiple ones at the same time. And we find that iron and zinc and also vitamin A are often co-located geographically. So our aim is to put all three of those together ultimately into one variety and deal with all three deficiencies. So apologies to those who've heard this story before, but golden rice contains beta-carotene. It contains a full suite of carotenoids, a particular chemical which give the rice that distinctive colour that you can see in the topmost picture there. So there's 2 genes that have been incorporated to do this, all right? And that's phytoen synthase, which comes from maize and or corn, and as you know, that's been eaten for thousands of years. So we say that in our regulatory approvals that it's got a history of safe use. And then the final enzyme that was needed to complete that pathway was phytoen desaturase, and that came from a common soil microorganism. And because it's in soil and in the dust, it's probably been consumed for thousands of years as well. But during our regulatory phase, where we've sought to have the safety of this product verified, we've looked in much more detail at the proteins that are produced by that phytoen desaturase to demonstrate its safety. Excuse me. Now, golden rice it's those 2 genes that have been inserted into an ordinary variety of rice. Okay, and so golden rice is not just one variety. That particular construct can go into any genetic background, and in fact our aim is to have golden rice available in a whole suite of varieties for different growing seasons and for different stresses, different geographic regions. But of course we've got to start somewhere, and so we've chosen common varieties to go into in the Philippines and in Bangladesh. Our aim is to provide 30 to 50% of what's called the estimated average requirement, and I'll explain to you exactly what that is in this next slide. So an estimated average requirement is a population-based measure. So if you look on the screen, you can see in the top left-hand side, there's a normal distribution. And all that represents is a population of people, and it looks at the levels, the individual nutrient requirements. So in other words, for a particular nutrient like vitamin A, some people will have a lower requirement, some people will have a higher requirement, but most people will be right in the center of that. And so the definition of estimated average requirement is that it's that midpoint of the distribution where you look at what levels are needed in a particular population, okay? So that's the estimated average requirement, and the recommended daily allowance for a nutrient is actually set much higher. It's usually 2 standard deviations of that distribution. So in other words, it's usually 1.8 times the estimated average requirement, and that's to ensure that everyone is sufficient for the trait. In that initial distribution there, you can see that when you put the line right in the middle, the 50% of the population to the right of the line is sufficient for that nutrient, and 50% on the left does not have enough of that nutrient for their requirements. So when we add 30 to 50% through golden rice, we move that entire cohort, that entire distribution to the right. And if you look down at the bottom figure there, you can see that when we move it to the right, we have much fewer people who are in that at-risk category where they don't. So golden rice has been a long time coming. Can I just confirm that I can still be heard? Is anyone still there? Someone needs
Yes,
to.
we can hear you, Dr.
Okay,
Russell.
okay,
Yeah.
good. I was just checking. I wouldn't want to be talking to myself. What we're up to with golden rice, and for those of you who've heard of it before, it's been. I guess that if I were to summarize, I'd say that's just because the process takes a long time. Okay, science has to work. Science has to generate, you know, some of these constructs. We have to test them. Sometimes they don't work quite the way we want, and we go back to the drawing boards. So part of this delay is all about getting the science right. And then because it is a product of biotechnology, we've inserted genes that aren't normally present in rice, then it's got to go through the entire regulatory process as well. And where we're up to at the moment is we've been through the laboratory, through testing the screenhouse, confined testing and testing in field trials, but under very carefully managed conditions. And we're now at this point where we're seeking regulatory approval. Now, we're fortunate in that we already have a food safety approval, so many places have already declared golden rice safe, and we submitted it in Australia and New Zealand, in the USA, in Canada, and we've also countries have come back and said golden rice is as safe as conventional rice that carries the extra benefit of beta-carotene in the grain. In the Philippines, we're just progressing now to the next stage of regulatory approval, which is where we seek commercial propagation approval. And in Bangladesh, it's a one-step process, and we're still waiting for the regulators to actually make their decision. So as I mentioned earlier, to be successful, something like this has to be an attractive trait at an attractive cost in order for the farmers to actually grow it. So golden rice is of benefit to the consumer, but the sad fact is that farmers themselves don't necessarily derive a direct benefit from it. So they're not going to get higher yields, for example, but neither will they have any lower yields, all right? So the best thing, or the thing that I think is going for us in terms of golden rice, is that we've put it into varieties with which farmers are very, very familiar. So these are varieties that they know and love. So BR29 in Bangladesh, and it's going into a range of varieties in the Philippines. And for the farmer, they don't have to do anything different. They grow the rice exactly as they've always grown the rice. And, you know, according to our testing, they will get exactly the same yields. It'll flower at the same time. Everything will be just the same, except that the end product will carry additional health benefits. So we're confident that we can provide the 30 to 50% of the estimated average requirement, which is what our aim is. And we'll be asking a partner organisation completely independent of us, but at an arm's length from us, to do an evaluation and feed it to people and measure the actual impact. A very powerful argument. In particular for governments to use this as an ongoing intervention to achieve their nutrition targets. In terms of farmer and consumer uptake, we have a big job in front of us. We need to educate not only farmers, but we need to educate consumers. And at the moment, we're really educating policymakers and and the nutrition sector. They know what's coming as well and can see the benefits in the way that it might be deployed and used. And so our aim then is not just to produce golden rice, push it out the door and see who takes it. Our aim is to have very clearly targeted pilot scale deployment areas. So we want to go in, we want to start small, and we want to have a targeted area where the deficiency is significant. And we want to go in and work with farmers and the value chain to actually educate them and have a sustainable intervention, so that when we walk away, when the job is done, it becomes a sustainable intervention that continues independently. And for that reason, I would argue that being able to advocate and communicate about golden rice is just as critical as the science component. All right, the science, in some ways I'd argue that's the easy part of this project. But it's very common, very evident to me that as we get really close to regulatory approval, that, you know, some public institutions are averse to making decisions, you know, critical decisions about something as fundamental to existence as rice. Now, I'm absolutely confident that there are no safety issues with this, but I also respect the process, all right? We have a regulatory system, and we aim to meet every last possible requirement that they have so that it can be scrutinised and people can feel very confident that the regulators have done a good job and that they've got a product that is very safe and will deliver what we say it will. So building public support is really important for us in order that we get those political decisions made as well. And of course, ultimately, we'd really like to shift the dialogue away from talking about transgenics and genetically modified organisms, because while it is that, right, I think the experience, as Dr. Ola has said, you know, these crops have been grown now for 22 years. There are millions of hectares, and there has not been one incidence of any harm that has been done by these crops. So I think the time has really come to move away from this sense that there is danger. I still agree that whilst ever there are strict regulatory systems in place, we absolutely have to follow those and meet all of those requirements. But let's not for a moment think that there are real safety concerns. Obviously, you know, communications is really critical to all of this, to getting the marketing and pricing and new partnerships to ensure a sustainable intervention. And I think my time is well and truly up. So I'll finish with this quote here, which is from Michelle Obama. So it's a bit out of date, I'm sorry, but I really like the fact that she focuses on having basic nutrition for children, and speaks about actually achieving their potential, because in the end, nothing is more important than ensuring that that all of our children, wherever they are, developed or developing countries, can achieve their potential. And for that reason, I always finish my talk with these beautiful children from Bangladesh and the Philippines to remind us that this is in fact the end goal of making our rice more nutritious. Thank you, and I'm sorry if I went over time.
Thank you very much, Dr. Renki, for this very enlightening presentation, walking us through the biofortification strategies. It's not just all about transgenics, but there are other tools, and also walking us through what the Golden Rice Project, what is it now, and still the hurdles to do. And it's good, it is moving. The permits for biosafety approvals for food and feed and processing have been secured, not only in the Philippines, but even from Australia, US, and Canada. This is really a very good progress for the project. Dr. Renki, we have some questions for you.
Yeah.
So, we have a question here. How is the bioefficacy of beta-carotene in golden rice compared to the equivalent in supplementation and natural sources? How is the effects of high temperature during cooking on beta-carotene in golden rice?
So
There are two questions there.
Sure. So just very quickly, in terms of bioefficacy, of course, that's a study that is yet to be done, but earlier work indicated that golden rice, the beta carotene in golden rice was absorbed with great efficiency. So if I can just get technical just for a moment, in green leafy vegetables, you often need lots of units of beta carotene of the order of something like more than 20 to 24 units of beta carotene to produce 1 unit of retinol, which is the vitamin A compound. Whereas with golden rice, the prior work indicated that you only needed 3.6 units of beta carotene. So it's converted very efficiently and effectively. It equates actually to having vitamin A in oil. So it's a very, very highly effective way of delivering delivering vitamin A, sorry. And how is the effect of high temperature during cooking? Well, the truth is that not only during milling and storage and parboiling and cooking, there are all opportunities for loss. And we've done a lot of measurement looking at the rate of decline over time during storage, but also during those processes as well. And in the end, the total loss during parboiling and cooking is around 30% of the total. And even after we account for all of those, we can still meet our target of 30 to 50% of estimated average requirement.
That's very good, because I think a lot of us are thinking what happens when you cook. So it's good to know that the bioavailability is still there. I have one more question for you, Dr. Renki. So we talk about public sector products and this golden rice developed by SIGIR in partnership with local research institutes. So the question here is that, how do you envision public-private partnership as you move towards the commercial cultivation?
That's a really good question. We think that there may well be a role for private organisations in the seed increase and seed production phase. And we would like to golden rice into the hands of farmers. I think it's highly unlikely that there'll be significant private interest in producing the crop, because, as I said, it doesn't actually yield any higher. It produces exactly the same yield as existing varieties, but carries added benefits for the consumer. And our aim is not to have that on the market at a higher price than anything else, because that would absolutely defeat the purpose of getting it to those people who really need it, who are often the ones who have fewer resources. So it's very important to us that it becomes available in the marketplace at exactly the same price as the rice that most people normally eat. So I think there are opportunities for the private sector involvement, perhaps in the seed increase phase, but I think less so in the actual production phase.
Thank you, Dr. Renki. I mean, I still have 2 more questions, but I think I will just read it. And so
I'm happy to answer these.
One time.
Answer these online as well, just by typing the answers.
Okay,
you need to move on. Yeah.
All right. Thank you very much, Dr. Renki. For our participants, please, Dr. Renki promised to answer this. So I'll wait for a while for Dr. Renki to answer your questions. Okay. So thank you very much, Dr. Renki. All right.
Okay, thanks.
Okay, so here we would like to move on to our final speaker for today. So he is from Hungary, and he completed his PhD in molecular plant breeding from Corvinus University in Budapest. And in 2004, he joined the Hungarian Seed Association as professional assistant. And in 2006, he was appointed to the position of Secretary General. He is currently the Regulatory Affairs Manager of the International Seed Federation. Today, he will talk about completely another topic, but still modern biotechnology. We will talk about new plant breeding innovations. So, everyone, let us welcome Dr. Salvox Rutner. Sabi, take the floor, please.
Thank you very much. Good afternoon, everybody, and many thanks for the invitation of CropLife Asia and CropLife Philippines to this forum. Indeed, my talk will shift a little from classical biotechnology, classical GMOs to more about gene editing, genome editing, and what it entails. So I try to share my slides. Today, I will try to talk two aspects of this genome editing, or we would like to talk about plant breeding innovation in a broader sense. I will share some thought about the regulatory and policy development in different countries, and what the global seed sector find important in this aspect. And in the second part of my presentation, I will speak about some of the trends which are visible in research and product development. Before I start, just a few words about ISF, the International Seed Federation. So we would like to see ourselves as a voice of the global seed industry. We are non-profit, non-governmental organizations, and obviously we recognize our members' contribution to food security and sustainable agriculture. If you see this map, you can see that we have a global coverage. Our backbone of our federation are the National Seed Association. So we have 58 National Seed Association who are our members. We are present in 75 countries, and directly or indirectly, we represent more than 7,000 companies. So just in brief, just to know what ISF stands for and who are we representing. When we are speaking about this latest breeding method, we always would like to put it into this kind of more general context of plant breeding innovation, because we see it as a kind of continuum of development which builds on the knowledge of many decades or even centuries. So we don't want to single out a type of application or technology. We always would like to see it as basically part of the toolbox of the breeder. So this is what breeders did in the past. We would like to create a genetic variability and use it for the improvement of our crops. So these latest breeding methods is basically part of the breeding cycle. So it doesn't mean that it will replace traditional breeding. It will be part of the process, but gives more choices, and obviously will increase the precision and the efficiency of the breeding processes in the future. Like for everything, every new technologies, the regulatory framework or the public policy has a huge impact on it. Because when we are speaking about the latest breeding methods such as genome editing, it's a I wouldn't say it's a cheap technology, but it's obviously widely accessible for many part of the stakeholders. So what it can make it an expensive undertakings if there's a high and overly high regulatory burden. So in that case, it will limit the access to some large companies, and also limit the utilization for high value crops and for a limited number of trades. So obviously we would like to avoid it, and therefore the industry right from the beginning was argued and advocated for clear and science-based government policies, which facilitate the innovation and collaboration, and obviously which is consistent across economies, because in the end we are living in a global economy, especially in the trade of agricultural goods, not just seeds, but all the commodities deriving from the seeds. So this was very early on agreed in the global seed sectors, that it's essential and it's key for I would say the wide access and use of genome editing technologies. Early on, again, we agreed on our basic approach. So you see highlighted here are underlying principles. So since the beginning, we have said that plant varieties developed through the latest breeding methods, such as genome editing, for instance, shouldn't be differently regulated if they are similar or indistinguishable from varieties that could have been produced through earlier breeding methods. So just to translate it to simpler terms, we said that something which could have been produced by traditional meeting, crossing and selection, or targeted mutagenesis, or random mutagenesis, I mean induced mutagenesis with chemicals and radiation, it shouldn't be regulated differently. So it shouldn't be regulated as the other classical biotech products, GMOs. They should be regulated as traditional conventional products. And this is what ISF and together with our National Seed Association, we try to um, advocate and outreach in different governments of the world to have this kind of common understanding and the same principles for policy development and regulation in different countries. Obviously, I cannot go too much into the details because I have a relatively limited time frame here, so I won't go to the details of the regulatory view of different countries. I would like to give you this kind of a brief overview that how is today the picture from the policy developments around the world. With dark green, you see the areas where there's a regulation in place. So there is an adopted policy on latest breeding methods, such as genome editing. And I think the best example is, and we see a very good alignment in the Latin American countries. So basically, they have a system when they see the products on a product by product basis. And the trigger of the regulation is the novel combination of genetic materials. So basically, if the product created by genome editing doesn't contain foreign gene, but it works in the gene pool of the crop, these new varieties are exempt from the biotech regulation of these countries. We have similar positive approaches in Australia. It's not as comprehensive as in Latin American countries, but some products, especially the SDN1 type of products, are excluded from the biotech regulation. The same true for Japan, and also in the United States, when just went through a kind of modernization of their regulatory framework, but in the US as well, certain products are exempt from the GM regulations. There are some countries in light green where are positive developments. There are no formal policy placed in yet, but hopefully it's gonna be will take a similar direction as in the countries I mentioned before. We have two good examples in Africa, in Kenya and Nigeria, and hopefully Philippines will join this bunch of countries. We have absolutely good news from developments in the Philippines with the regulators and the talks between the academia, industry, and regulators. Obviously, we have a bunch of countries here you can find in yellow where this discussion are already started, but we don't know the direction yet. So obviously, industry and academia are working to have a allowing and supportive type of policy decision, but we don't know yet. So the things are still a little bit unclear and under discussion in these countries. And at last but not least, obviously, we have some red areas where so far are restrictive decisions, namely the European Union and New Zealand. What is common in those two areas that in both cases, this is the result of a legal interpretation. So these are not a political decision of a new policy. Basically, this is the legal interpretation of the current regulatory frameworks in these areas, which means that it shows that the current regulatory framework obviously is not adequate for this new type of products. So in both countries, the discussion are still take place. partly because the current regulatory framework is basically not enforceable. So there are problems how to enforce it. So there are still hope, and especially in the European Union, there are good hopes that this can take a positive direction in the future. It will take some times, especially in the European Union. Things are not happening super fast, but we have good hopes that things will positively change in the future. In the second part, I will speak about new developments. What are in the pipeline? What type of products can hit the market in the future? It's relatively difficult to tell now because there are not so many. Actually, there is one product we are sure that on the market. This is a high oleic soybean in the US. All the rest, we have information, and basically one of the best sources and most comprehensive information is to check what are in the scientific publications. Obviously, this information have a couple of limitations that even the identified market-oriented studies feel not sure that they will be marketed because from the scientific publication, you don't have indication on this. Some traits and plants are just done for basic research. So for a proof of concept type of research or others. So, and this is difficult to distinguish that is there any commercial perspectives. And obviously, commercial companies are not really keen on publishing their research and product development. So when you see these pictures, you don't get the full picture because some of the activities, especially from the private part, are not covered in this publication. But if you just try to look for what is available in different journals, scientific journals, you can get obviously a lot of publication where gene editing is used in some crops. So these are the crops where the most hits you can get if you try the search function. And obviously rice, you can have more than 800 results, 800 publication with genome editing up till now. It's not a surprise because obviously rice is one of the model crop when researchers are testing their concepts and try to do some basic research. So obviously these are not all for commercial release. If you get a little bit zoom into what are the market-oriented applications, you get obviously less hits. So far there are a little bit more than 200 publication identified with market-oriented studies, mostly in China, US, Japan, Germany, and France. So these are the leading countries where the most publication was released. There are 41 different crops where you can find market-oriented applications, mainly in rice, tomato, maize, wheat, potato, and soybean, but you see some of other crops that are still listed, and there are still some publication took place. What is also interesting to see the target of the application, and most of them are related to improve the agronomic value of the crop and the food and feed quality and biotic stress tolerance. So these three account more than 70%, more than 80% basically for the applications using genome editing. So this is something we can learn from the publications. The other indication is the so-called MI-regulated process in the US. I said in the beginning that they have changed the regulatory framework. So today they have a different type of approach, but until August, there was possibility to check with the regulators the products made by genome editing, whether it's considered GM or not. So up till this date, 60 developers or 50 type of products have been notified to the USDA. And just to see also a kind of snapshot that it was total 59 crops. Here see also there are some more frequently mentioned crops and used crops like soybean, potato, corn, canola, and rice. And also these are the composition of the different characteristics uh, what the researchers or the developers want to improve. So it's product quality, pest resistance, and yield improvements, for instance. And I think what is also very interesting to see that the type of the developers who were behind these products, and it's both private companies and the public sectors. But as you see, the composition of the private sectors, these are not big multinational companies, but mostly small startups and developers who as main focus are genome editing. And again, doesn't really necessarily means that these products will hit the market. So it's still a kind of consideration for the developers to achieve a commercial release. Another concrete example, and these are my two last slide from Argentina. I said Argentina, there is a process in place, so developers can consult their regulatory agencies and check whether the products are considered as the GMO or conventional products. So far, there are 20-something products has been notified to this authority, and none of them deemed to be GMOs. So these were conventional products. And here also you can see in the green column, this is reflect to plants, the type of application has been done with genome editing. So it was also related to the increase of the agronomic value and the users and consumers added value for this application. And again, it's an interesting to see that who were behind those products. And here you can see that the majority of the products have been developed by local companies or public research. Some of them are foreign small and middle-sized companies, and only 90% for developed by multinational companies. So again, it reflects to the picture that this technology is accessible not just for the big companies, but for academia and local companies as well. This is my closing slides. So we believe that the latest breeding methods provide opportunities to target global challenges as well as local needs and can help us achieve sustainable agriculture production. And here are some references I used putting together this presentation. So you have any interest to dig deeper in this area, you can use this publication. And many thanks to your attention.
Thank you very much, Dr. Rutner. I may just call you Sabi. So, Sabi, thank you very much for this very educational and informative. Truly, science advances very much ahead of regulation, as you were saying, and as we are seeing from that map where each of the countries, where they are in terms of policy developments around genome editing. So we believe that the latest breeding methods provide opportunities to target global challenges as well as local needs and can help us achieve sustainable agriculture production. And
I don't hear you, Sonny. I don't know, but it's with my connection or.
Hello, can you hear me, Sabi?
Yeah, I hear now. For a moment I lost your voice, but I can hear you now. Yeah.
Exactly. Yeah, me too. So we are trying to work this out. Anyway, the question is, why do we have more publications on PBI in rice than other commodities?
Yeah, I think I already mentioned during my presentation that many publication it's not intended for product development, and as far as I know, I never worked with rice, so I think Dr. Rink have more information, but But what I know that rice is a model crop for this type of research. It has a relatively small genome compared to other Gramineaceae species, which are sometimes tetraploid and so forth. So it's more difficult to work with. So this is the main reason that rice has been mentioned many times, because this many occasions this used for a proof of concept type of research.
Okay, thank you very much. One more question, if we can. So here is a question that asks you to elaborate more. What is the importance of having a consistent approach to genome editing?
Yeah, I think the best thing is that we are living in a very globalized world, and especially true for seed trade. In the past 10-20 years, it's quadrupled the international seed trade. So even if you get a nice regulation in your country, obviously is not enough that you can utilize fully the technology, because then you will always have a threat that if it's considered GMO is in the other countries and this product is traded globally, what will happen if these products enter in the country where is the jurisdiction that is regarded as GMO? So then you can all have all the complication about testing and advantageous presence and low-level presence and all type of regulatory problems, which obviously can decrease the appetite for developers to commercialize products before having a full understanding of the whole regulatory framework globally. And if it's not positive, it's of course it's not an encouraging thing for them. And it's not just for the seed trade, but same for the grain trade. So for predictability, you need a consistent and aligned regulatory framework globally. That's for sure.
Thank you. But since we still have a little bit of time, Sabi, here is a question which says, we have advances in transgenic to genome editing. The advances in genome editing right now, the research, they get a lot of public sector investments in R&D, leaving a little bit or less investment to other plant breeding tools. What's your opinion on this?
I don't think this is I wouldn't see as a kind of competition between different methods. It's obviously and this obviously depends on the regulatory outcome. This is something which is accessible for broader range of stakeholders, and obviously I didn't want to mention, because it's not really the case at the moment, but genome editing could be used as a technology to create transgenic crops. So it's possible. So it's another tool in the toolbox of the breeders, which makes possible to have more precise and efficient changes on the plant's genome that was case in the past. So, and it depends on the purpose and the objective of the research product, that what type of tools in the end that the breeders will use in their breeding project. So it's not a competition of different tools. Yeah, we definitely don't see it. We would like to have, and this is our mission, to have access as many as possible, and which can enrich the breeders' tools for the future.
Thank you so much for that very insightful answer, Sabi. So if there are more questions around that, so Sabi will answer your question, and we will try our best to answer that question via email as well. So we go to the next part of our session. May I just ask a minute of your time to answer our poll, actually your feedback, and that is going to be shown on our screen. All right. So here is the feedback. First question, overview of modern biotechnology. So let us know whether you're extremely satisfied. Just check on that. Okay. All right. So the second question is what is your reaction with regard to the topic, the golden rice experience? Again, it is extremely satisfied, average, dissatisfied, or extremely dissatisfied. Our third poll would be if you could rate also your satisfaction regarding our topic on overview of new plant breeding innovations. Okay, so I just click on that, which answer you feel best right now. And then on number 4, this is about our overall session today. So again, this is our overall session. Yes. Sorry, we're just having very unstable internet here. So are you done? Okay, click submit when you have done. All right. Okay, I think that's very, very easy. So we can go to our fun part of the session. All right, so are we ready? We wanted your feedback because we will use this information to improve our future webinars. Okay, yeah, so let's wait, and then we'll ask our support if everybody has submitted their feedback. All right. This is really, I can imagine Dr. Rinky. Okay, everybody has submitted already their feedback. Thank you very much. Now we move on to the last part of our program, the super fun. An exciting part because we are giving away USD $20 shopping vouchers. And the mechanics are simple. So we will show you one question and you have to type the answer on the chat box. The answer should be the letter corresponding to your answer. And then you click enter, okay? So the first 3 persons to get the correct answer wins, okay? So everybody ready? Are you ready? All right. Maybe better to have a countdown, okay? We will show you the question. I hope my is ready. We have a countdown in 5, 4, 3, 2, 1. Show the question. All right, so I will read the question. For 10,000 years, farmers and breeders have been developing and improving crops. Which of the following are milestones in plant breeding? Crop domestication, hybrid breeding, mutagenesis, transgenic technology, marker-assisted selection, genome editing, all of the above. So write your answer in the chat box and only the letter, okay? So, while everybody answered already, we will choose the 3 winners. We will announce that. And the correct answer is, I see many who submitted correct answer. It's letter G, all of the above. So while we are waiting for the names of the winners, let me invite you again tomorrow, same link, same time, 1 to 2:30 p.m. Philippine time. Tomorrow we will talk about biosafety regulations and hear the experience of the roads to commercialization of GM crops. Okay. So now for the winners, let me check if we have the names of the winners already. All right, so we have the names of the, thank you, Winsper. We have the winners. Oh my gosh, we have Shiv Kaiserin, we have Lovely, and Samson John Alfred. So we have 3 winners winning each a USD $20 shopping voucher. So congratulations to all the winners, and we will get in touch with you through email on how to claim your prizes. So again, our winners are Shiv Kaiserin, Lovely, and Samson John Alfred. Woo! Congratulations, $20 US. So once again, I am your moderator for today, Sonny Tababa, Biotech Affairs Director.